How's it going, everybody? In this video, we're going to go ahead and take a look at the next topic in our Layer 3 section, which is going to be static routing with both IPv4 and IPv6. Now, for those of you that are not familiar with IPv4 or IPv6 static routing, the concept is actually really simple. And we're going to dive right into a quick little whiteboarding scenario to understand what is actually happening, what we need to be aware of, and some of the different types of routes that we potentially could see when we're doing different configurations. So I'm going to switch my color over to red. So when it comes to just regular routes, so we have static routes, right? The static route itself is a route that's always on, it's always enabled, and it is going to be the most specific route, meaning, or the most preferred route, I should say. So you're going to have the concept of the syntax is for on an iOS device, because we're going to take a look at this on XR as well. An iOS device is going to be IP route, and then you're going to put some sort of prefix in here. So for example, we'll put in 172.16.21.0, and then 255.255.255.0. And then normally you're going to put some sort of next hop. We'll say 10.1.1.1. Okay, this is what they refer to as a recursible static route. The reason why it's recursible means that you have to have a way to go in and look up what interface is assigned to 10.1.1.1. So the IP address of 10.1.1.1 or 10.1.1.x is going to be tied to a particular interface. Well, let's say, hypothetically speaking, that this is gig 0/1, for example. Okay, no harm, no foul if it's not. But the router is going to have to go look in the routing table and go, okay, this is my destination right here, my destination prefix that I'm trying to reach. This is the subnet length that I'm trying to match on, right? So this is the prefix length. So I'll put prefix length. This is my next hop, right? And then what it has to do is kind of go looking and go, what interface is that IP address assigned to? Oh, it's assigned to gig 0/1. That's why they refer to it as a recursible static route. Now I can take the same configuration and I'll type an IP route. I should say I'll write out IP route 172.16.21.0, 255.255.255.0 out gig 0/1 with the next hop IP address of 10.1.1.1. This is what they refer to as a fully recursed static route. I'll put SR in there for short. A fully recursed static route. And this is basically what ends up happening when we roll out something with a static route where we tie a interface and the next hop to it. So the router doesn't have to go in there and go, I'm not sure. Let me go look at what interfaces are configured and let me see what configuration needs to be applied. That's already taken care of with this and with this. Now, one thing that can be added here, it's an optional config, so I'll just put OPT for optional, is a name. So in the event that you need to name your static route so that it's easy for someone to identify what it is you're trying to reach. So I've seen names where it might be like site to wireless LAN net. You could do something like that, where you could actually name your static routes. So in order to get to 172.16.21.0/24, you're going to go out gig 0/1 to 10.1.1.1, and somewhere that's going to point you towards site 2 for the wireless network. That's an example of what you could potentially throw in there. Now that's a static route going to a subnet, right? We're matching on a subnet because we're not defining an IP address right here. We're defining a network ID, not a network IP. Network ID means a subnet range of some type, and then this is the length that we're trying to match on. Now, can you go and create a static route for a specific host IP address? You sure can. And that a host static route static route is going to look like this. IP route 172.16.21.16 255.255.255.255 out gig 0/1 to 10.1.1.1. You don't have to put in the interface. You can just put in the 10.1.1.1. So this could be placed right here if you wanted to, and you can eliminate the outgoing interface. That's an option as well. But this is what they refer to as a host static route, because you're being specific. You're saying this is the most specific route you can ever have, because it goes to a specific IP address. Now, the last one we're going to talk about is going to be the default route. Most of you guys should be familiar with a default route. Now, what's a default route do? It is going to be the catch-all route for anything that doesn't have a more specific prefix. So let's say, hypothetically speaking, that you have a bunch of static routes in your routing table to get to a particular set of destinations. No harm, no foul if that's the case. But the point being is, in the event that that does pop off and you need to have a catch-all route and you don't have anything more specific, the default route is going to be there to catch that. Typically speaking, the default route is going to be what's used in order to get you to the internet. So the default route is going to be propagated down from another router through dynamic routing of some type. And it's going to get you to that particular router, which will have a default route or other more specific routes. And that configuration looks something like this. IP route 0.0.0.0 0.0.0.0 out gig 0/1 to 10.1.1.1. And then you can name it default, for example. So these are all options that you have when it comes down to setting up static routes. Now, the IPv6 variation of that is actually very, very similar. Let me go ahead and clear the screen. IPv6 static routes are the exact same way. So in this case here, it would be IPv6 route. And then you would specify for a default route would be ::/0 to a next hop IP of whatever that might be. For example, it might be 2001:21:1. That could be that, or we could say let's do 2001, or let's say we do FC00:10:1:1:1. So to mimic what we just talked about. That's an option as well. This would be a default route. If you wanted to have a more specific route, something that was matching on a prefix, you could take this portion right here. You could take that and make this a FC00:172:16:21:/64, and then you could have the next hop pointed towards here. That would also work. If you want to do a host specific route, you could do that too. You could take that same logic and do FC00::. Actually, I'm sorry. This would actually not be a colon. I take that back. Let me erase this piece right here. That would not be a colon, because the colon would be right here. Now the reason was, why is there a space here? Because that could be a 0 or any other variable. But you could take 172:16:21:16/128 and then point it towards this next hop IP. That will also work. So it's up to you and how you want to determine which way you go with the configuration. It really doesn't make much of a difference which way you go. Now with iOS XR, the configuration is just a hair different. iOS XR has a process for everything. So for example, if you want to create a static route, you don't type in IP route. You type in router static, and then the address family, address fam IPv4 Unicast, and then you put in whatever range you want to put in, 0.0.0.0/0 out 10.1.1.1, or you could put in here 172.16.21.0/24 to 10.1.1.1. It's up to you on how you want to do the configuration, but that's basically what you would do in this configuration. Fairly straightforward stuff. So let's go ahead and take a look at actually doing this little bit of configuration. It's not too terribly involved. We're going to start on iOS 45, and we're going to create a loopback on router 6. We're going to configure this little setup right here, get it up and running. Same thing with iOS 45 to XR21, and then we'll configure XR21 to point a static route towards iOS 6 and go through all that. Pretty straightforward config. Let's go ahead and take a look at how that's going to work out. So I'm going to look at iOS 45, which is way over here. So I'm going to go to global config. Host name is iOS 45. I will type in interface gig 0/0. IP address is going to be 200.21.45.45/24. I'm going to no shut the interface. I'm also going to go interface gig 0/2. And I'm going to hit the up arrow to go back to here, but in this time here it's going to be 100.6.45.45 and no shut this guy. And then we're going to go over to iOS 6, configure him real quick on interface gig 0/3, IP address of 100.6.45.6/24. No shut the interface. And interface gig 0/2, IP address of 12.6.21.6/24. And then interface loopback 0, IP address of 6.6.6.6/32. And then what we're going to do is host name is iOS 6. Now that I have that in play, I'm going to go on to XR21 and get him configured as well, just so we can have this all on the same page, right? I'm going to go to, well, you can type in the password, right? There we go. Go to global config, host name is going to be XR21, and then interface gig 00002. IP address is going to be 200.21.45.21/24. No shut. Interface gig 3 will be the same thing. This time it'll be 12.6.21.21/24. No shut. And I'm going to go ahead and commit that config. Fairly straightforward configuration. Okay, now on iOS 45, let me go back over here and do show IP interface brief. I have both of my interfaces up. On XR21, I'm going to configure my static routes on, and let me go ahead and I'll do the IPv4 config first so you guys can see how that works, and then I'll turn IPv6 on. So on iOS 6, what I'm going to go do is, if I do show IP route currently, I don't have a route in the routing table to 6.6.6.6. So I do ping 6.6.6.6. Oh, I'm on the wrong device. I need to be on 45. My fault. Do show IP route. Do ping 6.6.6.6. I get a whole lot of nothing, right? So we're good to go there. I'm going to create just a normal static route, so IP route to 6.6.6.0/24 to 100.6.45.6 and hit the enter key. Okay. Now that I've got that in play, do you think I would be able to ping router 6? Do ping. Let's just hit the up arrow a couple times. You betcha. Because if I do show IP route, I have a route in the routing table that tells me to go to that particular subnet. Okay. Now I could take this out and notice how it says a 66000/24. If I was to come in here and create another static route, but make this one just a little bit more specific, 255 to 6.6.6.6, and do a show IP route again, notice I'm going to have two static routes. I'm going to have one, the subnet that goes to the 6.6.6 network, and I'm going to have a /32 static route that points me out towards 6.6.6.6/32. So if I do ping 6.6.6.6, I'm going to be able to get there all day. But if I get rid of the original static route that we created, hit the up arrow a few times, go back to here, type in no IP route, and do a show IP route again, that static route is now gone, and I can come in here and do the ping again, and it works just fine. That's how you configure a static route on a particular device to get it to do what you want it to do. Now, if I wanted to create a default route, I could as well. I'm not going to do that right now, but the syntax would basically be this: all zeros to wherever it is you're trying to send your traffic. So in this case here, I might say 100.6.45.6. That static route right there would work 100% of the time. Let's go take a look at this on iOS XR. And on XR21, we're going to come over here. Now we have the configuration, do show IP route. We don't have any static routes in the routing table, so if I do ping 6.6.6.6, I'm not getting anywhere, right? So if I Control-Shift-6 on that, or Control-C, and I need to go create a static route. So I can type in router, go to global config, router static. Underneath here, I need to specify the address family. I have address family IPv4 Unicast, and then I need to determine where it is I'm trying to go. So I can type in 6.6.6.6, or I'm sorry, let's do 6.6.0/24 out towards, in this case here, it's going to be 12.6.21.6. If we do the show config, that's my syntax. I'm going to go ahead, I'm going to commit that config, give that a couple seconds to apply. And if I do show IP route, now I have a static route in the routing table, and if I do that ping again, do ping 6.6.6.6, I can get there all day long. That's how you create a prefix static route. Now, if I wanted to take and hit the up arrow and change this to be a host-specific route, I can type in 32 and then do a 6.6.6.6, show config, right? So it updates it to be a host-specific route. I can commit that. Do show run router static. There's my syntax. If I hit the up arrow a couple times and do that ping again, the ping works, which is what I would expect it to do. We're in good shape. So with all that being said, that's the static routing aspect of the configuration. Fairly straightforward, okay? So now we're going to go switch gears and test out some quick IPv6 routes, because they're fairly easy to get running. It's just a matter of typing the commands in. Now, the only thing that I have to do on iOS 45 and iOS 6 is I have to enable IPv6 unicast routing, because if I don't, the static routing won't actually take effect. So I'm going to type in IPv6 unicast routing on both devices real quick. And then I'm going to go underneath interface, loopback. I have to go configure the new IPv6 interfaces as well. So I'll do this on iOS 45 first. So interface gig0/2. I'll type in IPv6 address. In this case here will be, I'll type in 100:6:45:45/64 and do that. And then I'm going to go over to gig00, do the same thing. I'll type in IPv6, actually I can just hit the up arrow a little bit here and remove these first pieces right here, 200:21 and 45:45, there we go. So that's in place now. I'm going to go over here to iOS 6 real quick and get that configuration in place. Where did it go? Did I accidentally close it? Oh no, it's right over here. So I'm going to go to interface gig0/2, IPv6 address of 12:6:21:6/64. And then I'm going to go over to gig03 and hit the up arrow, and we're going to put in 100:6:45:6. There we go. So now that I've got that in play, I'm going to go to interface loopback 0. IPv6 address is going to be 6 colon. Let's do something a little bit different. Let's keep the format. 6:6:6:6/128 colon right there. There we go. Gotta have that double colon in there, or else it won't work. So what I'm gonna go do is on iOS 45 now. I'm gonna go in here and type in IPv6 route to 6:6:6:/64, and I'm gonna go to, in this case here, it's going to be 100:6:45:6. So show IPv6 route. Do show IPv6 route. We can see the static routes in there. If I do ping 6:6:6:6, I can get there all day long, right? If I go to iOS XR and do the same thing, the same concept applies. So on XR, I'm going to go do this, XR21. I'm going to go ahead and get out of this one and type in router static. Actually, I need to go configure the interface real quick. So interface gig00003, IPv6 address is going to be 12:6:21:21/64. Commit that. And then I'm going to go over here to router static, IPv6 Unicast routing, address family IPv6 Unicast. And then I'm going to put in 6:6:6/128 and point it towards 12:6:21:6. Do a show config to see the route. This is going to be a host specific route, not just a /64 like we did over here on iOS 45. That's what we did here. We did a /64 in the configuration. So basically we did a /24 mask here, the equivalent of that. I'm going to go ahead and commit that config, and then I'm going to ping, once it commits, do ping 6:6:6:6, and I can reach it. And that's really, at the end of the day, what we really want to be able to do. It's a very, very basic lab, that's true, but the point being is we need to match on those. We need to be specific in the routing. Now you might ask yourself, well, I thought you could only use 2001 and FC, as your addressing. That is technically true in a production environment. But in this case here, I'm in a controlled environment that I don't have internet access to, so I can pick up whatever I want and use it. So in the real world, if you are going to be leveraging IPv6 internally, I would follow the RFC guidelines and use the FC ranges for your internal routing and get that up and running. So use the private IP addressing version of IPv6, which is the FC range. And then if you're going to be doing it on the public internet, you're going to need to go out and get a public IPv6 block. And the provider is going to give you one. Whatever that might look like, I honestly have no idea. It's probably going to start with 2000 something. But beyond that, I don't know. So, but in this case here, it's a controlled environment. As long as it mimics an IPv6 address, I'm in good shape. Because you can use pretty much whatever you want. As you can see, I'm doing here. I can populate whatever fields I want. I'm just mimicking the IPv4 addressing. So keep those things in mind as you're moving forward. Until next time, guys, thanks so much for stopping by and hanging out with me. Please like, share, and subscribe, and I'll catch all of you in the next video.